look at composited reflections over parallel lines. So I just wanted to remind you of what it looks like over intersecting lines. Remember, we're going to choose one line first, and we can reflect A. Maybe not. Let's try that again. We're going to choose a line. We're going to choose A. We're going to apply. There's A prime. And then remember, we have our second line of reflection, which is this line, but we're reflecting this object to apply. So we have A. This right here would be a double prime. And then this would be, didn't mean for that to happen. There we go. This is a prime, and then this is a double prime right here, reflecting over it. So we're going to look at this, but we are going to do it with parallel lines. So we've got right here, we've got two parallel lines and an object. So I am first going to make a line of reflection. I'm going to choose the one closest to my object and reflect it. And it goes right there. And then I am going to do another reflection, but I'm going to choose this second line and this second object, and we've moved it to there. So we're just going to see what this looks like. If we were going to construct this, we've got right here, we went from B to B prime to B double prime, or C is right here, C prime, and this is C double prime. I think C is the best way to see that we move down 1, 2, 3, 4. We've moved down 4. And if you look, it is a translation. It's the same orientation if we go from the first one to the second one, the original to the second. And if we look, the distance between here is 2. So if we want to go from C to C prime, it's 4, but the distance between the two lines is 2. So we can say the result of a composite over two parallel lines is a translation. But we can also say that the amount of the translation is twice the distance between the two parallel lines. Now we're going to talk about direction. So if we go back to our original, and I'm going to trash this, and we're going to get rid of those two reflections. Let's say we reversed where we're going from it. So if we were to reverse that, we're going to do reflection, but we're going to choose the second line first of this original object. And we've oops, let's undo that. We're going to do a reflection of the second line from this object. It does not like me today. This line of this object. And we're going to undo this. Try this one more time. Reflect this second line of this object. There we go. And then we're going to reflect again, but choosing this line of this object. And if we look, I believe we can, if I move this all down a little bit, you can see it better. There we go. You can see that it has moved up. It is still a distance of 2, so between C and right here, C double prime, it is up 1, 2, 3, 4. So if we reflect the bottom line first and then the top, we move up. So if we go back to our notes here, the direction of translation is the direction from the first line of reflection to the second. So these are our 3 important points right here. The result of a composition over 2 parallel lines is a translation. The amount of the translation is twice the distance between the 2 parallel lines. Again, that means because this distance right here is 2, The translation from the original to the second C double prime, not C prime, C prime's down here, but C double prime is twice the distance. So that's 2, so this will be 4. If these two lines were 3, this would be 6. And the direction of translation is the direction from the first line of reflection to the second line of reflection. So that's it for our reflecting over parallel lines composite.